So I suppose building a wee bit on Cian's fantastic presentation there, with Machine Eye, we're really focused on two areas at the moment. We're focused on our sites, on our physical workplaces, but we're also focused on our buildings, on our infrastructure, on those more traditional workplaces or enclosed workplaces in the light of all that's going on. So here at Machine Eye, we're primarily interested in sensing. How do we build buildings that understand their use? How do we build machines that understand their use? How do we use sensors for a safer environment? That's very much something that we need. Now, just this morning, as I was getting prepared for this presentation, I actually seen there's an article today in the Irish Independent. And so I've very quickly dropped that in, but it's by Darren McCullough in the Farming Independent. And I encourage everybody to go and read it. It's how many more fatalities will it take before the farm sector grasps the nettle on safety. And really what he's discussing is the comparison between our construction sector 10, 20 years ago, the progress and the procedures that have been put in place with SafePass, SafeCert, with the increased prevalence of health and safety compared to our farm sector. And the reason I say that is with Machine Eye, we're focused both on our agricultural sector and on our construction sector. In agriculture, we have a huge problem with personnel safety. In construction and in quarrying and in those related sectors, we have the same problem. We have the same machines. Time and time again, you'll see incidents occur, and the common thread throughout all of these are the people involved. So I want to do just a small demonstration that we have done of a typical farming accident. Now, this is very common. Current safeguards are in place. And with this dummy, really, you'll see the impact that these typically have when these machines are left on the Typically here in the UK and Ireland, we have between 50 and 100 fatalities every year across our agricultural sector, but that's not the true figure. The true figure is really those who have been seriously injured, who have received life-changing injuries, whether it's through crush, entanglement, collision. These really are where the problem lies. You know, we have in excess of 2,000 on the figures that we have, in excess of 2,000 people per year are falling. They're being crushed, they're being entangled, and that's devastating. There's communities, there's families. It's a huge impact, not to mention on our businesses. The problem really that lies is the machines themselves. Now, the manufacturers, before I go any further, the manufacturers do everything that they can. The legislation is there, the procedures are there. This is through no fault of the manufacturers. It's just by the nature that in our workplaces, we work with large machines. My background is I'm from a farm here in Northern Ireland. I've previously worked in the utilities sector. I've previously worked in the renewables. I'm an electrical electronic engineer, so I've had a broad visibility of all of this. So anybody on the call that's really familiar with these machines will know that regardless of what you do, there is blind spots, there is operator fatigue, there is operator complacency, particularly where there's repetitive tasks taking place. But by the nature of what we do, repetitive tasks are part and parcel of the day. So we need to try and mitigate that, try and control that, and that's really what we believe with Machine Eye technology has that impact. A few years ago, Caterpillar did a blind area study on their machines, and really what it shows is with the best design intentions, with the best forethought, it's impossible to avoid blind spots around these machines. There has been various technologies. There has been ultrasonics, there has been radar. You would be very familiar on your own car with the parking sensor type technology that will indicate objects around the machines. We do have blue lights, we do have various systems at the minute, but the common trend throughout all those systems is that they are reliant either upon a human reaction or they're not specific to a human around the machine. So if you take a typical site where there may be operatives mixed in with pallets, mixed in with all the machines, it goes back to the psychology of a human, that if a system like that, such as the ultrasonics, is triggering regularly on a regular basis, the effect of that alarm is lost. People switch off to it, and they don't pay attention. And that's where we have seen a lot of these incidents occur. They occur when people are under pressure. They occur when people are fatigued. Cian briefly touched on, we have a reducing workforce. We have a workforce that are working under immense pressure. So that's where we are seeing incidents like this occur. So going back to the sensing, so really what we believe here with Machine Eye is that there is a better way to sense, to understand the environment around us, the environment around a loading shovel, the environment around a digger, the environment around a tractor. And that really is with what's called edge processing and computer vision. So taking I suppose a typical machine, we know where the blind spots are on that machine. We have studies such as the Caterpillar machine. We have access to the machines here. We can augment using modern sensing the operator. We're not replacing the operator. We're not removing the need for the operator to be responsible. We're providing an extra layer of protection for them. So at those times when a person is fatigued, when they're distracted, where they're complacent, that is where technology steps in, and that really is where the direction we believe technology is heading. It's not to replace, it's to assist and to augment people. Whether that's in inspection, whether that's in sensing, we can build systems that accurately and effectively augment the person. So in the case of Machine Eye, on our core system fitted to an industrial machine, what we try to do is understand the use case of that machine, understand what people in the environment around it are doing, and work to augment the operator and the people so both work cooperatively in a safe and productive manner. We fit sensors into the machine, and these are vision systems primarily. Now, the reason that we use vision is that we can discern the environment around the machine. We can look, just as we as humans can look at an environment. I'm looking here now and I can see straight away that there's a laptop, that there's a door, that there's a TV screen. That is something we naturally do as humans. We look at a scene and we can tell what's going on, and that's why our eye is still the best tool for perception and the best tool for identifying risk. We have a natural ability to do that. However, what we're building with Machine Eye is digital vision systems that can do that same process in real time. So we fit our camera systems and our sensory systems to a machine in a very prominent, very highly visible area. We use artificial intelligence. So we've designed algorithms that use computer vision techniques to look at an environment, and we filter that environment. So if there's a human, another machine, and an object, we will actively pull the human out of that scene, and you'll see a demonstration of that soon. We look at that human, and using the same techniques we as people would use, we look at the movement of their limbs, we look at their direction of travel, we can understand how that person is going to interact with the machine. So if we see that that person is going to step into a blind spot, or maybe they're already in a blind spot, and that there's a rate of closure between the machine and the person, that's a very high risk scenario. So that's where we will intervene. Now, we can intervene on a sliding scale and as is appropriate for the use case. We use a technique to alarm that gives operators immediate vision of where the person is. So it's one thing to set off an alarm, it's another thing to give spatial context to that alarm. We can go right the way up to automatically stopping a machine if we have to. We plug into the onboard electronics and we do that. So we would all be very familiar with some of the videos that have gone round of accidents, or we may have had one on our own site. Being able to stop that machine in those critical seconds makes such a difference. The fact that we use vision systems is really a step leap. In agriculture and in construction, they're not clinical environments. They're very difficult environments for a sensing system to operate in. Radar systems can get confused by dust and dirt. LiDAR systems the same, they white out. And by using a camera system and by using visual processing, that effectively gets us around that problem. We can look at a scene, so if a human can see, our system can see, and we have a few other technologies stacked in underneath it to give us fall over. We use custom processors. These are known as edge processors. Up until now, a lot of AI algorithms, a lot of computer vision techniques, they would be run on the cloud. So they're connected to large servers or they're connected to large computers. They have a real-time internet connection, and that processing, that computer vision is done in real time on the cloud. That's no good for a site. Even a site with the best connectivity, there is a round trip latency. So we need time. If you're using traditional techniques, you need time to capture that image, stream it up to the cloud, process it in the cloud, and stream it back. Even with a strong connection, in the context of stopping a machine or making a safety critical decision, that's just too slow. It's also too unreliable. So what we do is we use edge processing. That power that was traditionally in the cloud, and that technique that was traditionally in the cloud, is taken to neural processing units that are put on our processors inside the machine. That effectively takes the decision to the point of sensing. And this is a trend that's coming up, not just in what we're doing, but in buildings, in everything at the minute. It's moving processing out of the cloud and to the point of detection and to the point of sensing. That gives us very low latency, very high performance, and it makes us, it basically means we don't need to have real-time connectivity all the time, which allows us to run on farms, on sites, indoors, in areas where there is issue with this. So that really is something we're very excited about. The edge processors that you would be familiar if any of you drive a Tesla. Tesla is one of the first automotive companies to put these into their vehicles. So the Tesla Autopilot runs on similar processors, larger processors, but similar processors. And that's really how they're making such quick decisions. So we're going to see over the next few years a lot more technology move to the edge. This is going to become a lot more common. There's a lot more processors, there's a lot more electronic suppliers bringing out systems to enable this. So that's really something we're going to see in the next few years, and it's going to be transformative. Just as an example of what we do, I've run a few, our system wouldn't usually overlay graphics, but we have overlaid identification graphics just to show performance. So what you're looking at here is looking rearward out of the cab of a digger. This is really indicative of what an operator would be seeing. You can see there's a very obscured area behind the machine. There's more or less no visual vision to the left. It's a very challenging environment. Traditional systems, the trees would be triggering them, dust would be triggering them. With an optical system, as you'll see when I run the video, we almost instantly identify that there's a person there. And as long as that person is in our field of view, we have a positive track of them. So you can see a static image, very little visibility of a person. Straight away we have a track of them. As we start to move the machine, even though everything is skewing, to us as humans, we can handle the skew, but to a machine that's very challenging. As we skew, we're still getting positive identification. So the next demonstration really that we have is inside a warehouse. It's inside a poultry shed actually. There's a lot of dust in the air. There's very bad lighting. We have made the image a lot brighter. It's more or less a dark shade operating under blue light. We have machines moving about. We have outside light coming in, which is high exposure. So this is one of the worst environments that you can put a sensing system into. And as you will see, now it's not just as accurate, it's something we're working on at the minute, but you'll see on a vision-based system, we're identifying humans even at times where I myself would struggle to identify. So you'll see we're getting the bounding boxes, even with the human up in the light at the moment. There is a bit of a false positive here on the machine, but that's something that we're working on, but we're more or less running in pitch black at this stage, typical of inside a commercial facility. So really the potential for computer vision in these environments is huge when it's underpinned with edge, and that's something really that we're working working quite extensively on is the use of computer vision in these environments. The last demonstration really that I have of the computer vision here comes from Denmark. The footage is 10 years old from Denmark, and the reason I use that is it's such poor quality. It's fine to do this when you have 4K cameras or you have modern equipment, but the fact that this is grainy footage, it's jumpy footage, it's very poor. We have multiple people who are deliberately trying to avoid the camera. You'll see that we have track and we have trajectory on them the whole time. So it's really agnostic to a lot of use cases of these systems. So we're constantly identifying people with a degree of confidence. Based on that degree of confidence, we're able to make decisions on how we control the machines. So as you can see, even with lack of contrast, with optical flares, we're still all the time having positive identification of the human targets. So really the potential for computer vision in construction, in agriculture, in these industrial environments is huge. And that's what we're doing here with MachineEye. We're working around bringing in a system that is very quickly fitted to these machines. It's retrofitted. As I said at the start, the manufacturers of these machines make fantastic machines, but they will only go as far as the legislation really requires them to. Taking that next step is very much on the employer, and it's very much on the insurer, and that's something that we're working with, is really to benchmark this as an insurance product, really to benchmark this as something that is very valuable to the industry. And we're working with a few partners at the moment to pilot that, and we're hoping to bring a few more partners on to continue those pilots and expand that out over the next 12 months. But we are really, to a certain extent, a design house. We are computer vision. We work extensively with computer vision and sensing. So one of the things we've been doing lately is taking the same algorithms, the same processes, the same systems that we use out in the field, and bringing it back inside, back into the office to try and improve, similar to Cian, make our buildings smarter, to give them the ability to report on themselves, and with COVID to provide some means of getting back to normal and creating safer environments for all those who are going back. So a big element of building management at the minute is understanding who is in the building, understanding the use of the building. Are we making best use of space? Are we optimizing the flow of people through the building? How are we keeping people safe? This is particularly prudent for operators, for building managers, for those who are trying to instill confidence in tenants to come back in. Similar to Cian, we're trying to put and in a lot of cases we're using existing connectivity in the building. However, just yesterday I was most of the day on a spider boom doing first fix because we just didn't have connectivity in the building. So I know somebody asked about the cost of putting that infrastructure in place, and it is very much a case that a lot of our buildings, surprisingly, even buildings that are built pretty recently, connectivity or infrastructure is not there. So we have been out lately retrofitting that. So it is something really to bear in mind, is the infrastructure that's needed to support deployment of sensing into these buildings. But what we're doing at the moment is twofold. We're using devices that use one of our sensing technologies over doorways for enclosed areas, such as restrooms, such as offices, meeting rooms, where privacy is a concern. So we're using non-optical sensors in a small IoT device to report the occupancy of that. Obviously at the moment with COVID, that's very prudent. The building I'm here in at the moment, for instance, this room is limited to 2 people now, the restrooms are limited to 1, so we have the systems just operating like a traffic light. They're turning red and they're turning green. But they're also reporting back over the cloud, and that's giving real-time usage numbers of various areas of the building. So I know that the guys here are optimizing how they lay out the building based on where they know people are throughout the day. And for fire compliance, they now know exactly how many people are in the building at any one given time. The other side of what we're doing is the video analytics that you just seen, and the computer vision. We're using existing CCTV systems there, again, trying to make best use of the existing infrastructure. We're analysing, again, identifying people, analysing how they move throughout the building to identify high traffic areas, heat mapping where they are for the purposes of COVID, for identifying areas that need better cleaning, things like that, pedestrian flow, building usage. So we're fit to take existing infrastructure that is there, apply our analytics layer over the top of that, and gain really valuable insights about how the building is being used and try to optimize that as far as possible. We were moving in that, we found that buildings were starting to move, in Belfast here anyway, in that general direction. But COVID has very much accelerated that, for it's now almost an essential tool for getting back to this new normal that we have. So with MachineEye, really it's about it's really about using the power of computer vision, using the power of intelligent sensing, so sensors that are aware of their environment, sensors that are capable of making good use of the environment, and using that to derive far better outcomes for humans in those environments, whether it's in an office, whether it's in the field. So it's something we're very much working forward on. We're very excited and we've had great support with, but we're continuing that way. So, if anything that I've said today resonates with you, or if it's something you'd like to even delve deeper into, by all means, throw me an email. I always love talking to people. COVID has curtailed that a wee bit. I haven't been as much. I haven't been fit to attend trade fairs and that, but I do love talking to people. So if anything that has come up there today is something that you'd want to delve deeper into, by all means, drop me an email. But
thank you, Brendan. And we'll be certainly sending out this video to all the network and social media. Really interesting. I learned loads actually. Edge processing vis-a-vis cloud processing, the fact that you can get real-time, much quicker responsive data on the actual machine itself, as opposed to waiting for connectivity. That's really, really interesting. I don't own a Tesla. I'd love to own a Tesla, but that's another story. So any questions for Cian? It's a pity there isn't more safety officers and safety compliance officers from these construction companies here today, because this is really very, very important. As you know, construction sites are very dangerous sites, and as you say, agricultural facilities. I always thought agriculture was quite a sophisticated, technologically savvy industry, but I guess you're dealing with people, and people make mistakes, don't they? And maybe the culture.
And just by the nature of what we're using in agriculture and in construction, when you make a mistake, it's got quite severe consequences, and it's just by the nature of what we do.
Yeah. So any questions from anyone for Brendan before we move on to our last speaker? Okay, I mean, I know we spoke before we started this morning about these large manufacturing companies that manufacture these machines, and you would have thought, like Tesla, that they'd be putting in this edge processing technology into their machines. Have they been doing that?
It's starting to move that direction. Really, Tesla are the driving force behind it, and there's a whole backstory to that. In industrial machines, we're starting to see it. It's not really mainstream yet, but it's starting to go that direction. There's one or two manufacturers are very much pressing forward in that sense. The big thing really with the edge is what it enables. It enables a lot more autonomy than we already have, which is what interests a lot of people. Really what we see, I would expect, or what we'll see over the next 10 years is it'll become more standard in machines, but it'll become more standardized. So at the moment when we fit now, we're fitting our own processors, we're fitting edge processors. I would say in 10 years, there may come a point where we don't need to do that because manufacturers are putting in edge processors of a sufficient standard to run our systems and to a standardized platform. We really see platforming as the future here, that if we want to fit a system, we fit it onto a platform. If company B comes along doing something else, well, that platform is available for them too. There's a lot of benefits to that. the fact that we get a mass rollout of these edge platforms in machines is one, but it helps with adoption, it helps with enablement of new technology in these, and ultimately that will drive towards more autonomy than we're already seeing. So it's not,
I mean, there's a lot of synergy between,
but it's going that way.
Yeah, what you were talking about and what Keane was talking about around that idea of sensing. I mean, Keane, do you have any observation on that? You know, you talked a lot about the building reporting on itself, but obviously that you're dealing there with cloud technology. I mean, do you see edge processing being as part of the solution going forward for buildings? So that
absolutely. I think Brendan's approach to the edge is cutting edge. There's huge operational challenges in using the cloud to do the data processing. If your process involves sound or video, there's a huge amount of I think, as Brendan mentioned, network uplink. You know, you're sending very large volumes of data up to the internet and down again, and the costs of that start to skyrocket. So processing, I think Brendan would probably have a view on how critical edge processing is to actually achieve or sell solutions at scale. You know, that the costs of not using edge processing would probably indicate quite how high and costly it can become to do this stuff using the server, aside from the practical issues of latency.
Yeah, absolutely. You want to see my server bills. We do use, I have to stress, we do use the cloud here. So there comes a point where edge processing is by its nature constrained. To give it a knowledge, we have so much horsepower available on the edge. Once we put that device into a machine, we're curtailed by the ability of that. So when we go to do a lot of our algorithm training, a lot of our sort of core development work that is very computationally intensive, it needs a lot of horsepower behind it, that's when we push it to the cloud. But that's not real-time work, that's not affecting anybody's machine, that's us developing the algorithms. So we have built a hybrid technique really where the mission critical real-time decision making is done on the edge, but the post-time, the development, the training of the algorithms, it's aggregated from all the machines, so we get the benefit of all these edge devices. Data is key to all of this. We have to have vast amounts of data to annotate the process, to train off, to get the accuracy of these algorithms. So that data is fed back centrally to the cloud where time is not critical. We then do the processing there where we've got the horsepower. Cost is a big issue, but aggregating that, it just keeps it a lot more manageable than if you were running cloud instances for every device in the field. Between data usage and even just communication, the cost would be prohibitive. You can start getting into latency and things like that.
Yeah. Thank you for that, Keane. Any other questions for Brendan before we move on to our final speaker? Okay. Well, listen, I just wanted to wish you every success with this product. I think you've hit both you and Keane are right on the money on this one. And you know, it's interesting. If you look at the technology around, say, time-lapse technology that's being used, like companies like Evercam are using on construction sites, this is that's more of a monitoring and programming solution, monitoring solution. This is really focused around safety, isn't it? And actually, Keane, your solution is also safety compliance. So you guys should probably knock your heads together and see where where there's synergies there. So thanks very much, Brendan, and great. Wish you every success with it.
No problem. Pleasure.
Delighted to have found you on LinkedIn.